A short overview of NICA's main experimental facilities. Perhaps it is logical to start with a first experiment which, in practice, had begun before the completion of the collider. This experiment is called the baryonic matter at the nucleotron, conducted on the extracted beam of the nucleotron. This is more or less a typical detector for experiments conducted on extracted beams. The beam is moved toward a heavy matter target. The target is located at the entrance of a wide aperture magnet. There is also a system that identifies the particles and its types. The main purpose of the collider is to enable research on the production of strange and multi-strange baryons when interacting with heavy atoms and the production of superatoms in such reactions. Research is planned to be conducted on the interaction between quarks at a very short distance. The next experiment, which will be carried out on the collider, and it will be the first one to be carried out at the initial stage of the collider's operation, is the experiment on gold atoms, or rather, the colliding of gold atoms. The experimental facility is called a multi-purpose detector. Therefore, it is more or less a collider detector. Our laboratory has extensive experience in designing the systems and subsystems of such detectors. With the participation of our specialists, the main detectors were created based on the Tevatron collider in the USA, on the RHIC collider, and detectors such as the STAR and Phoenix detectors. Almost every detector of the Large Hadron Collider has components and systems created at our institute. Now, a similar detector will be designed for experiments at the NICA collider. It will be comprised of a system modeling particle trajectories formed as a result of the collision of heavy atoms, followed by the identification of their types and masses. The foundation of the detector is the tracking system located in the longitudinal magnetic field, which is created by the superconducting solenoid. At the moment, the engineering of all the systems of the detector is at the stage of serial production. The production of the superconducting solenoid has been launched, and its assembly is scheduled for 2019. The next detector, and the next part of the physics program of the NICA accelerator complex, is dedicated to research on the effects of particle polarization and particle spin. At the moment, a collaboration has been created and a concept blueprint of the detector has been prepared with the intention to further this field of research. A number of possible options for the identification of particles at the collision of the polarized beams, as well as the geometry of the magnetic field, which will be used for this purpose, is under discussion. Two alternatives are being considered, either solenoid analogues to the MPD detector or a toroidal magnetic field. The next experimental facility, or more accurately, experimental space, is related to the implementation of a program of applied science at the NICA complex. At the moment, the baryon matter at nucleotron experiment is being conducted in the existing experimental hall. The hall is about 10,000 square meters in size. People sometimes call it a hectare under a roof. The baryon matter at nucleotron and the detectors are located at the very end of the hall. At the beam separation site, two platforms are planned to be organized for carrying out fundamental research in radiation biology and for the testing of spacecraft microcircuits. And the oldest experimental facility at the nucleotron accelerating complex, not in the sense that it is morally and physically out of date, but in the sense that it's the first of its kind, the internal target station is at the nucleotron. During the first years of operation, it was the only facility at the nucleotron until the implementation of the continuous extraction facility from this accelerator. The method of internal targets was set forward at our institute in the 1960s. Now it is actively being applied at many other facilities. The internal target station of our institute makes it possible to use targets of various types, where the material is moved toward the beam, with targets consisting of a variety of substances, from hydrogen to tungsten. The target itself is a disc located along the path of the beam. There are slits in the disc with wires, films, and other types of targets. The disc is remotely moved toward the beam with the help of a stepper motor.